In our last video, we showed how you can create a segment set to represent your network in your deterioration model. We ended that video by showing how you can view and export the segment set to Excel and pointed out that the set does not yet contain any data that your deterioration model could use. In this video, we will show how you can join data from tables in your database into your model segment set so that your model can use those values for deterioration modeling. In Juno Viewer, this is called the data join feature. Let's look at how a data join works. If you imagine this white space is your Juno Viewer cloud database, then in the last step, what we did is to create into your cloud database in the Forward Works program table a new model segment set, which we called AA demo. And we pointed out that there's no information apart from the location data yet associated with this AA demo set. So in the data join, what we want to do is to take data from available condition or asset information tables, such as surfacing information, and we want to take certain columns, for example, the surface date, and use that to provide initial data information in this segment set. So, for example, from the surface date column, we want to extract the information so that we know what is the current surface age for each one of these elements. Similarly, we may have a table called RUT data, and we want to extract one of these columns and add it as a new information column to our AA demo segment set. In Juno Viewer, the data join feature makes this really easy to do. Let's take a look at how data join parameters are created in Juno Viewer. So here I'm in my Juno Viewer homepage, and to create or view data join parameters, I go to the Settings menu and I select Join Parameters. All my defined parameters will be shown for me. Now note that this step presumes that you have already got some tables in your database to represent surfacing information and RUT data. If you want to follow along with this video series and you don't yet have any tables representing surface information or RUT data, then I recommend that you just add some dummy data from Excel template into your database so that you can follow along with this tutorial series. And if you don't know how to add data to your database, then it's very easy. If you go to the Juno Viewer Help Forum and you just type in add new table, for example, then you will see there is a lot of information here about the types of tables in Juno Viewer Web, the add table page in Juno Viewer Web, and this will all show to you how you can add new tables, and it provides a fairly detailed set of instructions for how you can do that. And if you struggle, you are most welcome to get hold of us at Laundrix, and we will be happy to help you to add your data to your database. But the key thing to note is that you have complete freedom to add the tables you want and to manage that data, because it is, after all, your own data. Okay, so if we go back to Juno Viewer and we look at the data join page, what we want to do for this demonstration is to add a new parameter. So we click on the Add New Parameter button, and we can start filling in these labels here. So I'm going to add a parameter to contain my surface age, and I want to call it surf age, and I want to use that same name here as my parameter code. So this is more a user-friendly label, and this is the final code or the column name that will be added into your segment set, preceded by the word info underscore, meaning it's a custom information column. Note that this text that you enter here should be a single word without any spaces or special characters. Now I'm going to select the table that I want to extract from. And I want to select from my surfacing information table. In your case, it may be called something different. And I want to extract the column data called surfacing date. And I want to group the data using the latest recorded data that has more than 50% overlap with the segment into which I am joining it. You can also have some conditional statements here for row selection, but for this example we are not going to use that. Now for the case here where we are extracting a date column, we can use this handy feature to convert that date to a number of years to the day of calculation. And this is what we want to be using. And then very important, what happens if there's no data at a specific location? I recommend that you use a very clear flag to indicate there's no data. This means that if the join algorithm does not find any data for one of your modeling segments, it will simply put the text no data there. And you can then instruct the model and the join operation how to handle those no data flags. And we'll look at that in a moment. Okay, so I'm ready to add this join parameter. So I'm going to add it. And you can see I have my surface age new parameter added here with the settings that I've just chosen. Let's go and add another parameter for rut depth. So I go again, add new parameter, and I want to add the rut in the left wheel path, and I'm going to use the 85th percentile. And I'm going to use the same code as my parameter code. So rut in the left wheel path, 85th percentile. So here I want to extract it from the table called rutting data. The column that I want to use is the one called left wheel path mean rut. In your table it could be called something different. It's not that important. What date range do I want to use? Now this is important because JunoViewer knows that your data, certain tables can be date specific, meaning that your data is entered in surveys. And in this case, I want to use the latest survey grouped by 60 days, meaning that any dates within 60 days will be regarded as a single survey. And I want to use the latest available survey that will automatically be found for each one of your section IDs. Now, for each one of my modeling segments, I will most likely have several rut depth observations. How do I want to group them? You can see there's a high number of options here. Most of these are just statistics that will be used, and I'm going to use the 85th percentile, but there is also an option to actually use raw data values, which is quite an advanced feature of the JunoViewer modeling framework. So just take note of that, but for this entry-level example, I'm just going to use the 85th percentile. I don't want to multiply or modify my result. I want to extract it with 2 decimals. And once again, if there's no data, I want to enter the word no data very clearly. So I'm going to add this join parameter, and I can see there is my join parameter now. Now what I want to do now for these 2 join parameters that I've added, I want to go and look at the no data rules. Now the no data rules is a way for you to instruct the join parameter what it should do to look for available data if there is no data found on a specific segment. So you can click on no data rules, and then you can select these statistics. I recommend that you use for the level 1 method, which I will explain in a moment, mean value, and for the level 2 method, a mean value. And for level 3, you use a default rut depth value to use if you absolutely have no data available and you have to use a default. So I will use 5 millimeter rut. Okay, so let's just, before we go further, let's have a look at what this actually means. So let us imagine that we have got a section called with an ID 1234, and on this section we have some modeling segments, such as segment A, which has got 3 data points in it, segment B, which has got no data, and segment C, which has got some data available. Now notice that these 3 segments are all in the same lane. So how the data join or how the no data rules work is that in this case I'm instructing the data join operation. In the case of segment B, which has no data, it will first go and do the level 1 method to try and look for data. which means it will look for data on elements which share the same section ID and lane code. So in this case, it will take the mean value of all of these points that are available on the same section ID and the same lane. And that average of all these available values will then be filled in there. What happens if, in the case of a segment D, E, and F, which has got no data in this lane at all? Well, in any of these segments, the method will automatically first try and look for data points in the same section ID and lane. In this case, it will find none. So then it will drop through to the level 2 method, where it will search for data on the section which has the same ID. In this case, I've also instructed it to use the mean value of such data points. And then, in the case where I've got a section that has got no data at all, either on the same lane or on any other lanes, it will use this fall through default level 3 value. So that's the way that the no data rules works. I can also point out that we have an additional method which uses adjacent lane values. So it will look for segments in the adjacent lane that share the same overlap, and it can use those values instead of looking in a longitudinal direction as I've indicated here. So that is called the no data using adjacent lanes. And that is an algorithm that is found under the Tools menu, and I will not discuss that further here. But if you are interested in using this method, please contact Londrix and just ask us for some help. Okay, so I'm just going to add this set of no data rules, and my data join parameter has now been updated. And I'm going to do the same for my surface age parameter, which I've just added. And here I'm going to say that here I want to use also the mean value of the values in the same lane and ID or the same section ID. And if there's nothing available, I will estimate that the surface age is 8 years. Okay, now that I've got these two data join parameters defined, I'm ready to go and do my data join operation. To do that, I go to the Tools menu and I select Create Data Join Set. I'm going to select the segment set that I was working on, which is on network A, and I called it AA demo, if you recall from our previous video. And I can use different join parameters at the same time. So I want to join surface age and this parameter called rut left wheel path 85th percentile into this segment set. And there are different options. I can join the values into this segment set and download the result as an Excel file. But in my case, what we want to do is to add join columns to the selected ForwardWorks program as information columns. So I'm going to select this second option. Now, when I click on that option, Junoviewer tells me that if I've currently got some info underscore columns, some custom information columns, which has the same codes as those selected join parameters, the existing values will be replaced. So in this case, that's all right with me, so I'm going to click on OK. Now Junoviewer tells me that the data join result process has been initiated. This is a long-running process which has been scheduled to start on the server within the next 3 minutes. And I'm going to click OK, and then it will take me to all the long-running processes that are currently on the server that have been initiated by me. You can also find the long-running processes yourself under the Tools menu by going to My Running Processes. Now, because some of these data join operations can take quite long, depending on how big your segment set is and also the size of your database, it could actually take from 1 or 2 minutes to several hours. And because of that, the long-running process allows this process to proceed even if you log off from Junoviewer or you leave the office, it will still be scheduled to run on the server. And what you can do is to just check back in a while, maybe 4 or 5 minutes, or click here, and you will see when that process has started to actually run. So I can see that the status of this process is now changed. It's currently running, and I can just check back in a few minutes and see whether it is finished running or not. Okay, so here you can see that my join operation has completed, and you can see from the start and end time that this took about 5 minutes to run on the server. So I can now go and look at the results of my join operation. Just as when I created the segment set, I can go to the data menu and go to Forward Works Program and Segment Sets. And if I go and select my Network A and my AA demo segment set, I can download the result as an Excel file, just as I did before I did the data join operation, and I can go and inspect that data in Excel. Now, just like before, I've got a column here which has got some comments. In this case, there's no field comments yet added, and I've got my identification columns and my field comments sheet here at the bottom, which is also currently empty. And now what my join operation has added, as you can see here, are two new columns. And they are called info underscore surf age and info underscore rut left wheel path 85th percentile. Now notice that the names of the columns that the join operation has added are the same as the codes of the join parameters. Right? So if I go to Juno Viewer and I go back to settings and I go to join parameters, and I look, for example, at this parameter called rut left wheel path 85th percentile, you can see this parameter code here. That is the code that has been added to my segment set or my empty Forward Works program, but it is preceded with info underscore. So anytime that Juno Viewer adds custom information to a segment set, it is always preceded with info underscore, and that's quite important to note. So you can see that the join operation has now added these two columns with information and data extracted from the database, and this will then be the starting values for my deterioration model, and we'll look at how the model is actually going to be set up to use these values in the next video. So you now know how to add condition data from your database to your modeling segment set using Juno Viewer's data join feature. In our next video, we will show how you set up your deterioration model setup, DMS, to use the joint columns as initial values for deterioration modeling. If you would like to learn more about Juno Viewer's powerful modeling framework, or if you would like to receive notification emails for new videos such as this one, then email us today at info@lonrix.com. Thanks for watching.